Hello and welcome to this morning's Peer Network webinar with Code for America. We'll be discussing the landscape of GIS and web mapping, and it's brought to you by the Peer Network, which is Code for America's community of government staff who are really working kind of on the edge of innovation and trying to bring in progressive change to their jobs and change City Hall internally. And this is kind of where we get together, support one another, and create resources together and share best practices. So today's discussion is going to be about kind of how to discuss GIS and web mapping, as well as presenting kind of a glossary of all the tools that are available to GIS analysts and programmers so that you can kind of create a community and a conversation around the tools. And so this is intended both for those working specifically in GIS as well as for managers or really anyone who wants to have a better understanding of what geomapping is, the GIS world is. So it's kind of going to be from the 101 kind of all the way up, and we're not going to go into detail in any specific tools. We can at a later point in time if anyone so wishes. So to kick us off, I also just want to mention that on the screen where you're watching this webinar, right below it there's a list of some links that we'll be going over that you can follow along with. And then we'll make all the slides and presentations available after this hour. As well, if you have any questions throughout the discussion, please feel free to type them in right below the screen. Feel free to watch or enter questions at any time, and then I'm gonna queue them up after the initial presentation. So about the second quarter of last quarter of the discussion. So to kick us off, I'd like to introduce our kind of minds for the day. We have Lizzie Diamond, who's a current fellow with the Lexington team. Lizzie's a geographic information systems analyst, technical educational writer, and front-end developer. Most recently, she worked as a GIS technical writer for the Oregon Department of Geology and Mineral Industries. She helped organize women-focused tech and mapping-related events in Portland. Lizzie studied geography at University of Oregon, is passionate for community building, good cartography, riding bikes, watching college football, rooting for the Ducks, and, of course, playing handbells. And then we have Brett Lord Castillo, who joins us from St. Louis. He's the GIS programmer for the St. Louis County Emergency Management, which is part of the St. Louis County Police. In Missouri. He's a passionate map maker and helps organize a local civic hacking meetup, Open Data STL, and recently led the first ever Code Across, bringing together lots of community advocates. And as Brett can attest, it's usually, the open data movement internally is led oftentimes by the GIS analysts because you are the ones that are actually, doing the work, opening the data, working with it, and kind of really getting to know it. So it often is led by GIS analysts and programmers. So it's great to create a resource with all the tools and to kind of have you in-house. So with that, I will kick it off to Lizzie to start the conversation.
Awesome, thanks so much. Welcome, thanks for hanging out with us today. When talking about how we were going to structure this today, we figured the best thing to do and one of the most valuable things that you can have in your tool belt is knowledge of all the terms and the different parts of the field that maybe you don't get to work with every day. When I was a GIS analyst, I was working with one particular piece of software on one particular task, and I kept hearing these words around me that I didn't quite understand, web mapping and the cloud and JavaScript, and I wasn't really sure how it all fit together. So Brett and I thought today we would go through those things. We're not intending to really teach how to do things today. It's more of just a higher level understanding of the world of geospatial and all of the different facets that maybe we don't all get to play with every day. So I'm actually going to throw up some slides, and we will start there. Let's go ahead and start. So the official title is GIS Techniques and Glossary, Understanding the Landscape of Geospatial. And yeah, really excited to go ahead and do this today. So the goals of the day are to learn about the elements of the modern geospatial ecosystem, define some terms, identify resources, and understand the goals or why we might want to learn these things, and to discuss the role of geospatial community in open data and civic innovation, which is the space that we're all in as we're all involved with Code for America, and of course have lots of fun. And as Garrett mentioned, this is intended both for GIS analysts, people who work in GIS managers, but also anyone who's interested in learning more about geospatial. Brett, do you want to do some definitions?
All right, sure. Turn the definitions over to me. Just one thing I forgot to add to my bio there is, while Lizzie's an Oregon fan, I'm an Oregon State fan. Despite that, we're able to work together really well on this. Those familiar with the two schools understand what that means. So when we start talking about the idea of geospatial, the most basic definition is just as data associated with a particular location. So whenever we're talking about geospatial data, geospatial analysis, geospatial software, it's all different types of systems, data, and methods that deal with the idea of being able to use location to relate things together. Not necessarily on the Earth even, so you can deal with abstract worlds, you can deal with off-planet worlds like we do over here at Washington University in St. Louis. Moving on with that, oftentimes I've heard some hang-ups about what is GIS. Now, one of the first definitions you'll hear is like this definition from Esri, that it's a system that lets us visualize, question, analyze, interpret. And the big part of there is you're looking at patterns and relationships that occur in space. Now, but where a lot of times we miss the boat is on the idea of what's a system in this sense. You know, it's very tempting to be like, it's the software. So it's ArcGISDesktop or any other software packages we talk about. Well, really, the software is only part of that. We're talking about a system. We're also getting into hardware elements, data elements, and the big thing is the people are part of the system too. So whenever you want to talk about your geographic information system, understand that it's the entire grouping together of that system. In particular, making sure that you're including your people when you're discussing that. All right, and then.
You want to do this part? Yeah. You want me to do this part?
Why don't you go ahead and do this part, and I'll chip in if I come up with some more.
Okay, so you know, we use maps in government for all kinds of decision making, but also for displaying and sharing information. You know, there's all different types of analysis we can do. We can determine how many buildings are within a 10-block radius of a school. We can determine how long it takes to walk from one place to another. We can also determine, okay, based on how we allocated funds in the last budget cycle, which populations are receiving most of the benefit. And even beyond that, we create and maintain geographic data, and we ensure the accuracy of that data, because it does help not only us make decisions, but other governments, citizens, anybody who's interested can take our data and use it in decision making and in understanding the world around us better. But really, the list is infinite. Every individual department, every individual person has a different reason for using maps and different techniques and practices for using maps.
As so much of government is the location and allocation of services and resources, so we're always concerned about where our users of those resources are, and the people who need those services, and where those are distributed. Especially working in emergency management, we worry a lot about the idea of where a resource is at right now and where it needs to be used. So a lot of what we do is inherently a geospatial problem. But a big way in which we specifically use maps in government is communicating with the public. It used to be, you know, the classic map is the USGS topo, which communicates huge amounts of information. Now, as we're moving forward, a lot of times when we communicate with the public, it's not in the form of a paper map anymore, but specifically in the form of a web map. And so that's the very first section we want to deal with here, is demystifying the idea of web maps. There's so many different tools out there, and we want to just kind of review for you what some of those tools are, how you might utilize them, and where you can find them.
Totally. So I don't remember what the next slide is, so I'm going to peek. Oh, great. Perfect. So what is a web map? A web map, quite literally, is a map that exists on the web. That is the base definition of what it is. Typically, it's interactive and such that you can click on things and they display different types of information. But ultimately, it's a map that's on the web. In the ArcGIS sense, actually, though, it's a little bit of a different definition. In the ArcGIS Online landscape, a web map is an actual physical, or not physical, but an actual element, an embedded element that it exists in a JavaScript object format that you can, is a packaged thing. So if you notice the background of this slide, this is HasView, which is the statewide geohazard viewer from my old place of employment. And because this is made with ArcGIS Online, this is actually packaged as a web map, and you can take that element and move it around. So it includes all of the different layers and the interactive nature of it. But on a more abstract sense, a web map is a map that is on the web. It has a few elements to it, and there are lots of different tools that we can use to make web maps, which we will go over now. You want to go talk about CartoDB?
Sure, I can attempt to talk about CartoDB. Yeah, I'll tell you, for all of our listeners out there right now, Lizzie and I aren't experts on every single one of these, so we'll try to answer our questions as best as we can. And we have our favorite tools as well, and different tools are better suited to other fields. So CartoDB is one of those options you may hear about with web mapping. We'll talk about some of the more widely known ones a little bit farther down too. So one of the big things with CartoDB is that we'll see is common in a lot of these tools is the idea of data hosting and analysis to go with it. So CartoDB provides you a relatively easy way in order to upload tables of data, which can then be turned into spatial data if necessary, if it's not already spatial data, and then being able to create your visualizations on top of that. With CartoDB, you'll probably look at it immediately and be like, hey, there's a bunch of plans in here. Am I going to have to pay for it? Well, no, that's not necessarily true. Like many of these options, you can go ahead and get a free account. You just have to start playing around with it initially and get an idea of how to use it. Then when you realize how it fits for you and the type of resources it makes available to you, that's when you can look at the idea of creating a paid account so you can hold more information, so you can host maps available. That's going to be true across a lot of these resources.
Yeah, oh, go for it, sorry.
Oh, but anyways, I was saying one of the big things with CartoDB is it has some really easy and very strong, as you can see those examples back there, cartographic and analysis tools accessible right away when you upload your data.
Yep, that is exactly what I was about to say. And it's in browser, which is really nice. You don't have to download anything. The next one is ArcGIS Online. Probably of all of the web mapping things we're going to talk about, this is the most familiar. ArcGIS Online is a data hosting and web mapping tool. They have a lot of templates inside of ArcGIS Online that allow you to just add your data. And geographic data, right? We're not going to get too much into this, but geographic data, as we said before, anything that has a location associated with it, whether that's CSV, shapefile, GeoJSON, KML, any of these data types, ArcGIS Online can handle all of those, and ArcGIS Online also will integrate nicely with ArcServer, and a lot of governments actually host their data on ArcGIS Online. But it's an in-browser editor. You can create web maps that other people can interact with, and you can pull data natively from wherever you're hosting it if you're using the Esri ArcGIS ecosystem. Plus, they have templates and story maps that are appropriate for various different types of information that you're trying to share.
Lizzie, can I jump in and just ask you to explain a little further about being in browser? Or needing to
sure, yeah. So in browser means that you open up your Internet Explorer, Firefox, Chrome, whatever web browser you use, and you have the whole suite of tools available to you inside of the browser. You don't have to download anything onto your desktop or onto your machine. There are software programs that you like QGIS or ArcGISDesktop that do require you to be on your desktop and do larger analysis. If you're going to do lots of geoprocessing, you're going to want to and like do a lot of analysis. Typically, you can do that work better on a machine than in the browser. Because of the computing power required to do that. But with web mapping, it's all very lightweight, which is very nice. There's not a lot that is required. It has a lot of heft. And so these in-browser editors are really nice because you can use them anywhere. You can share them across machines. You don't have to send a file around. You can just send a URL, and someone can go ahead and use them.
Now, one quick thing here
yes.
Probably some people get confused about with ArcGIS Online is the whole idea of ArcGIS Online public account versus an organization account versus the different types of organization accounts. So one thing you can do with ArcGIS Online is just create a public account. So this is just an account just for you. It's a kind of a personal account where you can go ahead and upload some data, create maps, use the geometry service, and author maps online. For that account, there's no real organizational aspect to it. So every map you're making is public out there. Whatever you're putting up can see it. You also have a limit on how much data you can store. And every piece of data you upload, every map document you create, also you can build applications using ArcGIS Online, uses up your data limit, which is just 2 gigabytes. And this can handle an awful lot. So if you just have some sort of one-off use or so that you want to be able to make a public map with, it can be very useful. It also is limited to non-commercial use. So if you're going to do any sort of business use, you're going to have to create an organization account. Then over on the organization side is where we're getting into the paid subscription service for ArcGIS Online, and it is often called ArcGIS Online for Organizations. With this, you're getting a certain number of users and a certain number of credits. So the number of users is the number of actual named accounts. Sometimes you'll just get away with one account that you just need to publish everything. But if you're going to start creating private maps and private groups that you're sharing over the internet, you're going to need more named users on there. The credits are just kind of a measure of usage. So every time you geocode, which is converting an address into the latitude-longitude location, you store data up, you create a map, all of those types of things can start using credits. Now you get quite a bit of credits with even the lowest level account. I've honestly burned like 3 credits in 6 months out of the 2,500 I get with the lowest level account. And on top of that, if your organization already uses ArcGISDesktop, you do get an organization account for ArcGIS Online with that. You need to talk to your account rep to figure that out. I'm not going to figure that out for you. But just being aware that there's 2 different things that we talk about there with organizations, ArcGIS Online for Organization and ArcGIS Public Account. Organization has a lot more capabilities and a lot more ability to store and the ability to do private groups. But most things you can actually do just with a public account.
And you may have a license agreement. Your city, state, agency may have a license agreement, so be sure to check with the people who manage your relationship with Esri, because you may have some of this available to you already.
Mm-hmm. And if they don't know, tell them to ask their account rep. They'll be able to help them figure that out. That's what we had to do on our end.
For sure. Mapbox. Mapbox.com is another in-browser editor. Unlike ArcGIS Online, it doesn't do a ton of data hosting, but which is like data hosting, which we'll talk about a little bit later, is a computer somewhere, machine that's holding onto your data and giving it to you when you ask for it. What Mapbox.com does is allows you to upload data and customize web maps that you can share, and you can also add data manually, points, lines, polygons, any type of data that you want to add. And you can style it however you want, and you can save it and share it. And you can also create data inside, like you can add points manually and then export those as a data set that you can use elsewhere. It's of all of these that we're going to talk about, I would say it's one of the most simple. You do need a free account to use it. There are other paid accounts that allow you more views. So they limit Mapbox will limit the amount of views that you get, so the number of people that look at your map. They also have a really nice satellite imagery layer, which you can use if you have some sort of paid account.
Yeah, but it starts pretty cheap on the paid accounts too. I think it's $5 a month or so.
Yeah,
so.
Exactly, about $5 a month.
Yep. Where you'll find Mapbox has gotten really popular in journalism too. So especially if you're on the government end of things, oftentimes when you start getting those sunshine law queries for spatial data, the intent is to use it on Mapbox. So even if you're not necessarily looking to use Mapbox for your own web mapping, it's a really good idea to understand how it's used and just take a look at how you upload data there, because it's going to help you better serve the media in your area as well. Part of the reason for that, and you can kind of see in this screenshot, you can make really detailed changes to your cartography. Mapbox is very good at making rich cartographic styles for some really pretty maps. I'm not saying you can't make really strong cartography with the other solutions. It's just a particular strength of Mapbox that makes it well suited for online media.
And we're not going to talk too much about desktop software today, but Mapbox also creates a desktop tool called TileMill, which is a cartography tool for making the base maps that go onto web maps, that sort of bright green, light blue background that you see there. Those types of base maps you can make with TileMill, so something worth checking out if that's something that you need. You want to talk about GitHub?
Sure. GitHub. Actually, it's my favorite option lately. It's not the sort of thing you really use for like an enterprise option for web mapping. It's not, if you need to make really pretty maps, if you need to make match specific purposes, it's probably not necessarily the way to go. But if you want to make your data readily available under your map and be able to get it up quickly, and especially I like to automate a lot of my workflows, so it allows for some really easy workflow automation. GitHub's a really nice option. The trick to this, as you can see, it says pdxplaces.geojson. So for those not familiar with it, GeoJSON is basically a particular format to place your data into. It's used with JavaScript, and the JSON part stands for JavaScript Object Notation. It's just a particular, think of it as a particular way of encoding data into text. And so you encode these objects into text that then can be read out by software, mostly in websites, in order to know what kind of data it's working with and how to render things. So GeoJSON format, you can find quite a bit of converters out there to get whatever your data set is into GeoJSON, can be loaded up on the GitHub. GitHub hosts code, in particular can host text, so you can host a GeoJSON file. Once you have the GeoJSON file up there, that's it. You go to that file, GitHub will actually render it for you on a map, and you're all done. Also, along with GeoJSON, there's another format called TopoJSON too. The main difference is for you is that TopoJSON is a lot smaller, so it's easier to host it without running into like file size limits. A quick, simple solution to push data out quickly and have it mapped as well.
Yeah, and GitHub just generally is used for a bunch of other things besides mapping. It is, as Brett was saying, it's an online code repository, specifically for code, but also for text. I know of people who manage essays, blog posts, ideas using GitHub because it is a way that you can put up ideas, share them, other people can share them, borrow them, edit them. And now with this GeoJSON rendering, you can actually share and use and edit geographic data as well. In one of the links down there at the bottom of the page, there's information on how not only you can add data to this map that you see here, but take this map itself and embed it fully into another website. So there's basically no work for you in having to create a map. The map is totally already made for you, and you can just take it and move it, which is really cool. Google Maps. So Google Maps we're all very familiar with Google Maps. We use the routing, driving directions, transit directions a lot. But and so Google Maps allows you also to like upload your own data or drop pins on the map if you want to show. These are all of the locations of parks and the different amenities that are in these parks. I've seen a few Google Maps versions of that, and Google allows you to do that really well.
Yeah, lots of built-in tools for finding directions, finding locations, and the familiarity. Everybody knows what Google Maps looks like. Everybody's pretty familiar with how to work with it. So if you do use Google Maps as a web mapping tool, you've got that built in right there. You're not going to have to create a whole bunch of help pages or anything. People are going to right away recognize it and have a good idea of how to navigate around your map.
Totally. Just looking, it's 11:25, so we're going to have to zip through some of the rest of the stuff. But of these options that we've mentioned, all of them are pretty much self-contained. You don't have to do any programming. You just have to bust open the website, follow the prompts, add some of your stuff. You can do some, click and drag customization, and you get mostly what you're looking for. The last option for making web maps is to actually build your own. And this is a nice transition into the next thing we're going to talk about, which is the role of programming in geospatial, in the modern geospatial environment. Because sometimes the options that we've described just now don't have quite the level of customization that you need for your particular map or for your particular web application. So this allows you to by building your own map, you can have a little bit more customization. So, on to part 2, the role of programming in geospatial. We're not going to go too in depth into anything here. This is more of trying to sort of define some terms and understand what these words mean when you hear them being thrown around, so you can be a part of the conversation or identify the things that you maybe want to learn a little bit more about. So the first place to start, you've heard us mention a couple times, is JavaScript. JavaScript is the language of the web. If you think about a website as a sentence, you have the HTML, which is the nouns. You have the CSS, or the styling, which is the adjectives. JavaScript would be the verbs. JavaScript is what makes your web page actually do stuff, in addition to just presenting information. And in a web mapping context, JavaScript is what is actually powering those web maps that you see on Google Maps, on CartoDB, on ArcGIS Online, and on Mapbox. Is JavaScript sitting behind there, actually making the interactions happen when you hover on something, and actually even drawing the map in the browser itself. JavaScript is it's a programming language. It has a lot of nuance. It's an older programming language also that has a lot of things that have been built onto it and into it, because it is the language of the web, and no matter what background people come from, if they're writing for the web, they're using JavaScript. In the web mapping world, there's a lot of different, what we call libraries, which are predefined sets of code that someone has written that you can just use. So I don't have to sit and figure out exactly what the logistics are of drawing a map in a web browser, because in each of these libraries, someone has already done that math, someone has already done that logic, and I just have to declare and say, okay, D3, I see that you have a one line of code that lets me draw a map in the browser, so I'm going to grab that. So there are 4 major JavaScript libraries that people use to make maps, and we can tell you a little bit about each one of them.
And sorry if your favorite one isn't here, but these are the main 4 out there, and especially for those who aren't familiar with these libraries, oftentimes these are the ones you'll see people turn to when they're making the decision of how are we going to build our JavaScript web map. And also, sorry, Flex, Flash, and Silverlight people, but at this point, JavaScript's winning the web mapping war. So that's what we're going to be covering. So D3, D3 comes from Mike Bostock over at New York Times. Now, it's not primarily a mapping library, which is one of its big strengths. It has lots of different ways to visualize data, including some very strong geospatial visualizations. In terms of format data, it likes GeoJSON or TopoJSON to drive everything, so be aware of that with this option. But lots of beautiful, very animated, interactive possibilities through D3, and very much worth learning. ArcGIS JavaScript API. So this API is designed to work with your ArcGIS stack. Oftentimes in government, there's already instances of ArcGIS server out there. It's also the library that underlines ArcGIS Online that we saw earlier. So this is constantly has new versions coming out, taking advantage of those new resources available from Esri. And it has really tight integration into those resources, so it can oftentimes do some very powerful analytical interactions.
I'm going to jump in here and just define API. So an API is, you're using it interchangeably with the word library. Basically, it is a set of rules and predefined functions that allow you to interact with an application. The I stands for interface. So, like I said, you know, the JavaScript library D3 has already defined what a map is. An API is doing the same thing. It's defining certain mechanisms for interacting with something else. So, ArcGIS JavaScript API says, okay, if you want to interact with your feature layers on ArcGIS.com, we're going to define a little bit of communication, a little function that allows you to do that.
Also referred to as how robots talk to one another.
Oh, I like that.
That's the definition on there. So open layers is an open source option on there. It works very well with what's called the open source stack. So you'll kind of hear it differentiate a lot of times between an ArcGIS or Esri stack and an open source stack. And it's mostly referring to the whole set of desktop software, server software that you use to create your data and host it out. These aren't monolithic stacks. You can actually mix and match between them. There's ways to use JavaScript API on top of open source servers. You can use Esri servers to run an open source web mapping. So don't think that you have to go completely one way or the other. Open Layers is kind of a transition right now. They're about to come out with their version 3, which basically offers newer technologies for how it draws that are going to greatly speed up the capabilities of your web map. The leaflet's another open source option on there, and actually feel free, Lizzie, to chip in on any of these with this, because I'm not, like I said, I'm not an expert on all of these. I'm trying to explain what I know about them. Leaflet's huge advantage, and you can probably even see it in our screenshot there right in the middle. It talks about weighing in just 33 kilobytes of JS. It's lightweight. When we talk about lightweight or heavy, it refers to the amount of code that your web map application has to download to the browser before it starts running. So Leaflet doesn't require very much code to download. It gets running right away. It doesn't take up a whole lot of space. It doesn't take up a lot of processing capability for your end user. It doesn't necessarily, especially right out of the box, doesn't have all the same capabilities of the other libraries. But then there's this idea of plugins. So plugin is where oftentimes other programmers have added more capabilities. Like there's a Leaflet plugin to make Leaflet work with ArcGIS Server. So you can mix and match those plugins you want in order to add more capabilities to Leaflet. You just don't use the baseline capabilities all the time. But again, the big advantage of Leaflet over the others, while being extremely functional, it's extremely lightweight to your end user.
And the reason actually that's why it's called Leaflet, is because it is so lightweight, just like a leaflet. And that's why Vlad named it Leaflet. There's one on here that I forgot, which is the Google Maps API, which is another one that is more common and very similar to Leaflet and ArcGIS JavaScript API. The Google Maps API provides a lot of the same functionality, but it does it in the context of Google Maps. And one of the big strengths of Google Maps is its directions and routing. One of the big advantages of using the Google Maps API is that you can use that functionality in your map. Which is very exciting. And it also has a very nice search. I don't know if you've tried to do map searches on other map engines besides Google Maps, maybe Apple Maps, that you don't always end up in the exact right spot, and Google has done a really nice job of taking what you're trying to say and translating it into a location that it understands. So Google Maps API can be really, really good for those things as well. And before we share these slides, I'll make sure to add that in here as well.
Also, a quick thing, be aware that for ArcGIS and Google Maps, there are some restrictions on licensing if you're going to use it for a non-public application. So pay attention to those kind of aspects. D3, one of the drawbacks is it's designed for modern browsers. You hope all your users are using browsers that can do HTML5, but if they can't, they might run into some difficulties that they might not with something like OpenLayers or Leaflet. So those are just some things to be aware of in there when you're making decisions on what type of JavaScript library to use.
Absolutely. And if you don't know JavaScript and you want to learn, I've found that learning through building maps is really helpful. It's how I learned.
How I learned too.
Because you're doing something you love and you care about. And we'll get into more a little bit later about how you can continue learning beyond this. But I think for now we should move forward and keep talking about programming because it's 11:35.
Yeah, we're a little wordy. We'll get there though.
So another programming language that is very common in the geospatial world is Python. You may have seen Python inside of ArcGIS, heard it thrown around, ArcPI. Python is great for geoprocessing and automation. So if you're doing a task where you have to run a buffer and then a select by location and then you want to dissolve and you have all of these different operations that you want to do all in a row, Python can be really, really great to string them together. Also, if you are not using ArcGIS and you want to do geoprocessing outside of ArcGIS, Python can be really helpful for that as well. ArcPI right away. Go talk about ArcPI, Brett.
Okay, so when you hear the phrase ArcPI, it's not something separate from Python. It's actually a library within Python specific to ArcGISDesktop. You have to have ArcGISDesktop license, or you can run it with ArcGIS Server as well in order to get your ArcPI script to run. But it's able to access all those different capabilities that the desktop software has, so it makes it extremely powerful. And it's probably going to be, it will be the most common geospatial scripting that you'll see, and the first one most people learn. You can run ArcPI from inside the ArcGISDesktop application as well, so that's another reason it gets used pretty heavily. But it's not your only option out there. There are other ways to do the same type of analysis you want to do with ArcPI, and so that moves us on to the idea of open source Python libraries. So these three, you may know these three names, but you may not know them even if you do geospatial Python: Shapely, Fiona, and Raster.io. So going from the bottom, Raster.io, like it sounds like, you use to interact with stuff in a raster data format.
Wait, what's a raster?
Oh, good question on there. I did not anticipate that one at all. A raster. So see that satellite image up there that we're looking at the top? That's data, but it's data just in the form of a big grid of values, just like when you look at any other picture. So when we're talking about something that's in a raster data format, it's basically in a grid of values or some sort of matrix of values, and you read those values individually out in order to assemble your geospatial data.
When you say values, do you mean pixels?
Generally pixels.
Cool.
No, it's not always an image though. So what's the example I was just thinking of? DEMs, digital elevation models. So in that case, each one of those grids is just holding an elevation, not really a value that translates directly into an image. You still display them on a map though as pixels.
Cool.
So Raster.io deals with raster data. Fiona takes a step in a different direction to the other really common data model, not the only one that uses geospatial data, which is vectors. So in government, our most common way we think of vectors is either as street center lines or as parcel boundaries. And so we're talking like points, lines that connect between points, or polygons where you're using line segments to compose a polygon shape. And Fiona is the open source Python library most commonly used for interacting with vector data. And Shapely, on top of all that, can do all sorts of different types of analysis operations. So if you want to make a buffer around a point, if you want to be able to intersect two sets of features together in order to create new types of new features from those, Shapely is the library you're going to turn to. All of these are really great at reading and writing out of different formats, especially Fiona and Raster.io. So you need an Esri format. You decide you need to be able to transform it over into GeoJSON or a shapefile to file geodatabase. All these different types of spatial formats out there. These libraries are very good at doing that. And there's a reason for that.
Oh, wait, what's the reason? Oh, is it GTall? Okay,
It's
cool.
GTall, yes. So GTall is well, there's a Python version of GTall. There's lots of versions to GTall, and OGR as well. Both of these libraries do transformation. GTall does, in particular, does raster transformations, just like we talked about. OGR does vector transformations, just like we were just talking
And
about.
so, and GDAL stands for, this is helpful for me to remember, is the Geographic Data Abstraction Library. And so what it does is it provides a lot of different communication tools for talking to data and asking it to do different things, particularly changing data formats, converting between formats, dealing with projections, which we're definitely not going to get into today, and doing basic geoprocessing. GDAL for rasters, Ogre to Ogre for vectors. OGR is like a relic acronym that doesn't actually have any meaning anymore, but that's also a fun story you can look up. I'm going to zip through here actually because of time, but
But just quickly, that last set of libraries, they overlay GTall and OGR, so they do the same things, just they're a lot easier to work with.
Right. Yeah. Shapely, Fiona, and Raster.io they sit on top of GTall and Ogre. They make them more fun. So SQL is the way that databases communicate. Really, when you're working with geographic data, most of the time you're actually working in a database. If you've ever done a field calculation, a select by attribute, any of these operations inside of ArcGISDesktop, you are writing SQL. You're writing SQL queries, and you don't even know it. It's crazy. So SQL is really powerful because it allows you to do things like joins and build relationships between different types of classes or different types of data, or different data sets. And there's a lot of ways that you can do that directly as well. So yeah, SQL, it's great. PostGIS or PostGIS is a spatial database, so similar to like ArcSDE. What do they call ArcSDE now? It's geodata. I think it's actually geodatabase.
Just say geodatabase now, yeah.
But it's one of the original use cases. The S in GIS stands for systems, right? Geographic Information Systems. The idea that it's very challenging to store geometry and geographic data, and it requires a lot of like weird ways of storing things so that they can be recalled quickly. ArcGISDesktop, QGIS, they do a really nice job of very quickly not only taking that data, but like rendering it and visualizing it so you can see it on your screen. So when you are selecting two polygons and merging them or dissolving them, really what you're doing is you're selecting two rows in a table in a database and combining them into one row while doing some math, which I know totally blew my mind when I first realized that. It's kind of crazy. But PostGIS does that same kind of work, and it extends an open source database system called PostgreSQL or Postgres, and it's really awesome and valuable and cool to use because it's very robust. It can do a lot of things, a lot of the same things that ArcSDE or ArcGIS geodatabases can do.
On an open source option, being one of the
on an open source option, precisely. It's a little bit hard to get set up, but once you get it set up, it's very cool. So when people say PostGIS, that's what they're talking about. So programming, analysis, web mapping, all of that's really great, but all of it relies on data. And so there's lots of different ways that we can store data. It's no accident that I put some clouds back there because I'm sure that y'all have heard of the cloud. The cloud. And the cloud is one of those ways of storing and hosting data. I don't remember what this next slide was. Right, okay, so there's many different ways to host data, and there's many different types of data. We've mentioned a few of them, and as far as types of data goes, there's PostGIS has a data format, your PostGIS data. Then you have your shapefile, your file geodatabase, GeoJSON, TopoJSON, KML, all of these pieces of geographic data and these data types need a place to live because if you have a web map, you are rendering this data on a page, which means it needs to live somewhere that your page can communicate. So your page reaches out to another computer and says, hey, I really want that data that shows me where all of the cupcake places are in Portland, and that computer says, all right, sure, awesome. And so that computer can actually be in a physical location. It can be off somewhere in a data warehouse, which would be the cloud, which is a hosted solution. And there are many different types of options for cloud hosting, including ArcGIS Online. ArcGIS Online is definitely one of them. In addition to just making web maps, you can use it to store and host your data. But another one that we mentioned previously is GitHub. GitHub allows you to put data and host it up there. Now that's just specifically for some of those smaller data formats like GeoJSON and TopoJSON. Any of the other data formats that we've talked about are larger, more robust, contain more information, and need a little bit more support in being hosted, which is why things like ArcGIS Online and ArcServer are valuable. The other ones to include would be Amazon Web Services, AWS. There's all of these different ways that you can host using Amazon, which cloud hosting allows
including S3. And when we talk about S3, you're basically talking about an option for just raw storage up on Amazon's host of servers. That's one you'll oftentimes hear thrown out on there.
Yeah, definitely. And then the other one that I'm going to quickly mention is Heroku. And Heroku is a place where you can store you can manage and host your applications. So if you're building a tool that isn't just displaying data, but is actually storing different types of functionality, different types of programming capability, Heroku might be another good option. Again, I'm going to just quickly zip through some of these last things so we have time to talk, to have questions. So the last part of our little chat here is about OpenStreetMap and open data. OpenStreetMap is something that people keep talking about because it's actually really, really, really cool. OpenStreetMap is like the, oh wait, hold on. Yeah. Okay, good, in the right spot. OpenStreetMap is like Wikipedia, but for maps. It is an online data set, massive data set, and anybody can go in and edit it and add data to it and even take the data and use it. People say, oh, but isn't that like Google Maps? And you say, yes, it is like Google Maps, except for on Google Maps, I can't select an area and download all the vector data like I can with OpenStreetMap. So OpenStreetMap.org is the place where you can go and learn more about that. It's crazy easy to edit, really fun. I like to do it for therapeutic purposes because I'm crazy, but it's very enjoyable and great. As we mentioned in the beginning, open data stewards, that's y'all. That's the GIS people, because like more than 75% of government open data across the whole country is geographic data. And there's lots of different types of data portals that you can use that allow you to host geographic data in such a way that people can download it and use it for themselves. And the common ones are Socrata and CCAN. Those are like two of the bigger open data portals. ArcGIS Open Data is like a brand new open data portal that they are pushing out now that actually seamlessly integrates with ArcServer and ArcGIS Online. You can go and learn more about that through their website. And then we talked a little bit about this concept of APIs, but an API is a way that data can flow seamlessly from your database system in your government agency through to the web, and then it lives somewhere on the internet where another person can send a query to it and say, hey, API, give me the newest data as it's happening, and it's this like seamless stream of data. So APIs are really helpful for continuous data, things like crimes, 311 phone calls, code enforcement calls, those kinds of things that are changing all of the time. Socrata and CCAN and ArcGIS Open Data are really helpful and provide APIs, which can be really, really great. As we mentioned, and we keep continuing to mention, is that like GIS analysts really are the stewards of this open data. A lot of government agencies will have someone who's in charge of updating the data. They'll do a data dump every year. But as a GIS analyst, if you care about open data and you care about the ability for people to make cool web maps and cool visualizations with your data and learn things about your city, you can be that person that is allowing for that to happen if you are able to understand a little bit more about all of these systems and how they work together. Just even knowing the vocabulary so that you know when someone says, oh, we're going to put it on a leaflet map, you can say, okay, I know what that means, and I'm going to now model my data accordingly, or I'm going to provide the right resources so that someone can actually, yes, take that data and put it on a leaflet map or do whatever else they want to do with it. So you really have the power as a GIS person to be able to do that, which is really great, and it warms my heart to see how many GIS analysts are out there in government really doing that hard work and putting that data out there. So kudos to y'all. It's really great. There are a couple different ways that you can keep going on this train and learning more. One of them is map time. And those who know me know I love to talk about map time. But map time groups are a series of hands-on, beginner-focused meetup groups for learning more about maps and geospatial, particularly web mapping, programming, web hosting, sort of these more technical aspects and web-focused aspects of geo. And learning communities are the best when we have a lot of different people all coming together and saying, hey, none of us really know how to do this. Let's get together and learn how to do it together. And it's proven to be extremely valuable. We now have 20 chapters. I believe the newest one is in Vancouver, British Columbia, and Detroit. Those are the two newest ones. If there might be a map time chapter in your city, if you go to maptime.io, you can look at a map of chapters and see if there's one in your city. If there's not, you can reach out to me or to anybody else in the MapTime organization, and we can help you get one started. If you're a beginner, it's great to start because I've learned so much more than I ever thought I would just by teaching, because you have to know something pretty well if you're going to teach it. I mean, but that's also not true because you don't, because you learn together. Oh my God, MapTime, so great. Another great way to continue doing this work and getting involved are the Code for America brigades. The brigades are local volunteer groups that are engaged and excited about civic tech, and it's technologists, it's citizens, governments, people who are excited and engaged and wanting to do good work in the civic tech space. There are brigades all over the country. If you go to codeforamerica.org/brigade, typically a GIS presence in these communities is great because so much open data is GIS data. So those can be really awesome.
Also, as a government peer, the brigades are one of the best ways to learn how people want to use your data to help you guide your own strategies and policies. Yeah,
that's very true. That's a really good point. In conclusion, this adorable cat wants you to remember that all of this stuff can seem really, really overwhelming and crazy, but seriously, just by knowing the words and having heard them before and like poking a little bit more into the things that interest you or you think might be valuable, like you're doing such awesome work by like staying informed and engaged. The more work that we can do in the web space and in the programming space, the more we can automate workflows, the more we can communicate via all of these different avenues, the better job we can do of being good stewards for our communities using maps and geography, these things that we love so very much. Also, I want to point out that this cat is wearing green and yellow, which are
I noticed that one. Yep. But he has orange fur.
Fair point. At this point, I think we'd like to open it up to questions. This bit.ly link doesn't quite work yet. At the end of this thing, I'm going to add a slide about Google Maps API, and then these slides will be available at this link. That's Brett's Twitter handle, it's my Twitter handle, that's Code for America's Twitter handle, and huge thanks to Garrett and the Peer Network for putting this on. It was very exciting. You can read more about the Peer Network at this URL, and I believe we would be happy to take some questions, if there are any questions.
Thank you for that. That was, I mean, my mind is so full right now, but Lindsay, thank you for, your great energy that you bring to the table, so clearly passionate about it. It gets it's contagious, gets others excited. I kind of want to go play with OpenStreetMap now.
Yay!
So we have one question. Can you talk from Jesse? Can you talk a little bit about going back to the tools, about the abilities of geocoding within the tools? They're kind of working on evaluating geocoding within across the sector.
Well, it'd be good to get one tiny piece of information on this, which is, are they talking about geocoding on the back end, where you were talking about taking data sets you already have with addresses and trying to add latitude, longitude to them? Or are we talking about geocoding on the front end, so talking about like in a web interface where you want a user to be able to type in an address and find where they're at, basically, or be able to use information about that address in order to do something? Now, could talk about both of them, because when we talk about front-end geocoding, basically it's in our web mapping libraries. Oftentimes, some of the tools we looked at there have geocoding built in, and they'll have a data source for you for those addresses. All of those JavaScript APIs that we talked about, all those libraries have geocoding built into them. The hard part is where you get your geocode from. You know, whether it's going to be Google's resources, ArcGIS Online has some resources built in for geocoding, or if you have to, like I would say, roll your own. So like with our geodatabases we have inside the county, we have this huge store of all of our addresses, all of our street intersections, and we use that in order to do geocoding of addresses within our county. Rolling your own isn't the easiest thing in the world, and of course you got to get more resources if you're going to deal with areas outside your own area.
So, sorry, go ahead. I do have an update from Jesse, though. They want the user to type in an address and find a nearby resource.
Oh yeah, and that definitely fits with what we're talking about. Every one of those JavaScript libraries is going to be able to handle that for you, as well as those web mapping tools. The trick is just going and taking a look at what's available and finding those data sources that are available to you. Whether, like I said, whether it's like ArcGIS's geocoder, OpenStreetMap has geocoding available through it too. So take a look at that resource there for a free online source of that.
And the line graph typically goes, the more accurate it is, the more expensive it is. So geocoding is one of the hardest problems in geospatial, just because of the variability in addresses. So different ways that people do different addresses in different cities. Google has the biggest data set. They have the most accurate geocoding, but it's also going to be the most expensive for you. So those kinds of trade-offs are what you have to consider. And again, your ArcGIS or Esri license may include a certain amount of geocoding already within your agreement with the city. So I would check that out.
Working within your own city government, you can talk to your GIS people about the idea of building a locator service or a geocode service that just uses addresses within your jurisdiction too. That's going to be, in some ways, the cheapest way in order to get that sort of geocoding, and they can make that available to you through a resource like ArcGIS Server or other server resources.
Great. We have another quick question in the last couple minutes from Gary, who asks, you said 75% of open data is geospatial data. What are some effective ways for getting that data out and making sure it's in a useful format for public consumption? Also, if we can just let them know about any links or more information for this statistic, that'd be really great.
So I have somewhere. I have a link that I'll find. I'll dig up and I'll send out that has information on that. Because so much open data is geospatial data, all of the open data portals recognize that, particularly ArcGIS Open Data, because it is a tool of Esri, which is a geographic mapping company. They are providing the ability to download data in formats that are going to be accessible. For the civic tech community, GeoJSON for geographic data is very, very, very awesome because it's so interoperable. You can use it in lots of different types of applications, and you can convert from GeoJSON to other formats and from other formats to GeoJSON quite well. A shapefile is the fastest and easiest one because you can kick it out from ArcGISDesktop really easily. And a shapefile is an open format so that other tools, regardless of whether they're proprietary or open source, can use a shapefile, and you can do analysis on a shapefile. CSV is also not the worst thing in the world for sharing data, so long as it contains geographic information. Typically better for point data, where you just have one latitude and one longitude that you have to keep track of per piece of data. Socrata has a mapping element to it, I believe. I've never actually used Socrata, so I don't know.
It will only do points, though. So if you put like a polygon into Socrata, it's going to transform into the centroid of the polygon. It's one of the understand from what I understand, they're working on being able to handle more shape types, but that's one of the weaknesses you have there.
And CCAN, the newest version of CCAN, allows you to it visualizes your GeoJSON file and allows you to download it. Another great way, of course, is GitHub, if you're feeling comfortable and familiar with GitHub to host data.
Also, don't overlook the file geodatabase, too. Even though it's been strongly tied to Esri, there is an open API available for it now, so a lot of those Python packages we talked about, a lot of other tools out there will actually handle file geodatabase.
Excellent. In respect of everyone's time, I just want to thank both Lizzie and Brett for sharing all their institutional knowledge of the GIS space, as well as our sponsors of the Peer Network, Esri, Socrata, and Acela. And you can reach any of us on, via Twitter, or feel free to email me as well at garrett@codeforamerica.org. And we look forward to seeing you on our next webinar. We have one next week about ETL and actually the technical aspects of getting data opened. So please do join us for that. So thanks again, everyone. And we'll be doing a follow-up, and if you would like to go a little deeper into any of these tools, we'd also be happy to do that in the future.
Thanks, everyone.
Thank you.
Bye.
Bye.